The DeWalt D-handle drill offers several advantages. Firstly, it is lightweight. Its compact design reduces fatigue over extended use. Secondly, the drill features an ergonomic D-handle, providing a comfortable grip and increased control. Thirdly, it boasts a powerful motor that delivers ample torque for demanding applications. Fourthly, the variable speed control allows for precise drilling speeds tailored to different materials. Fifthly, its compact size makes it suitable for working in confined spaces. However, there are also some cons to consider. Firstly, the drill has a limited speed range, which may not be suitable for very high or very low speed applications. Secondly, some users may find the cord to be too short for some tasks. Compared to a Milwaukee drill, the DeWalt D-handle drill is generally lighter and more compact. It's designed for one-handed use and may have a low speed range. If looking specifically for lightweight, compact, and ergonomic 1/2-inch drill for roughing in residential electrical work, the DeWalt D-handle drill is a solid option. The compact size and reduced weight make it easier to maneuver in confined areas. While it may have a slightly lower speed range than some Milwaukee models, it's still powerful enough for most residential applications. For even more power and versatility, consider an alternative like the Milwaukee 18 fuel brushless 1/2-inch drill/driver, which offers high torque, a compact size, and a wide speed range. Ultimately, the best drill for specific needs depends on budget, usage patterns, and personal preferences. Considering other alternatives to corded drills, there is a whole world of cordless options to consider. For example, different ampere batteries are an important consideration. More amperes typically means longer runtime. Consider the voltage of the cordless drill, with higher voltages often correlating to greater power. Evaluate the chuck size of the drill. Common sizes are 3/8" and 1/2", with 1/2-inch chucks generally accommodating larger bits and offering more versatility. Check the maximum RPM revolutions per minute of the drill, as higher RPM can be beneficial for drilling into harder materials or for faster drilling speeds. Note the IPM impacts per minute if the drill has a hammer drill function, as this indicates its effectiveness in drilling into masonry or concrete. Brushless motors are more efficient, durable, and require less maintenance compared to brushed motors. Consider the weight and balance of the drill, especially if planning to use it for extended periods or in awkward positions. Features like an LED light, belt clip, and multiple speed settings can enhance the user experience. Evaluate the warranty offered by the manufacturer, as this can provide peace of mind and protection against defects. Read reviews from other users to get an idea of the drill's performance, reliability, and any potential issues. Consider the availability and cost of replacement parts and accessories, such as batteries and drill bits. Think about any specific features or accessories needed, such as a side handle for added control or a depth stop for consistent drilling depths. When drilling, always wear appropriate safety gear, including safety glasses and gloves. Ensure the workpiece is securely clamped or held in place to prevent it from moving during drilling. Start drilling at a slow speed and gradually increase as needed, especially when drilling into hard materials. Use the correct type of drill bit for the material being drilled, as using the wrong bit can damage the bit or the workpiece. Apply consistent pressure while drilling, but avoid forcing the drill bit, as this can cause it to break or overheat. Periodically clear away any debris or chips from the drilling area to prevent them from interfering with the drilling process. If the drill bit gets stuck, stop the drill and try to remove it carefully using pliers or a drill bit extractor. Avoid drilling into electrical wiring or plumbing pipes, as this can be dangerous and cause serious damage. When drilling into metal, use a cutting oil or lubricant to reduce friction and heat, and to extend the life of the drill bit. When drilling into wood, use a wood drill bit with a broad point to prevent the bit from wandering and to create a clean hole. When drilling into concrete or masonry, use a hammer drill with a carbide tip drill bit and apply firm, consistent pressure. After drilling, clean the drill and drill bit thoroughly and store them in a dry place to prevent rust and corrosion. Inspect the drill regularly for any signs of damage or wear, and replace any worn or damaged parts promptly. Follow the manufacturer's instructions for maintenance and care to ensure the drill's longevity and performance. If unsure about any aspect of drilling, consult a qualified professional or refer to a reputable guide or tutorial. Be aware of the different types of drill bits available, such as twist drill bits, spade bits, hole saws, and step drill bits, and choose the appropriate bit for the specific application. When drilling deep holes, use a drill bit extension to provide extra reach and prevent the drill from overheating. When drilling at an angle, use a drill guide to ensure accurate and consistent results. When drilling into brittle materials, such as glass or ceramic tile, use a diamond-tipped drill bit and apply a slow, steady pressure to avoid cracking or chipping. When drilling into plastic, use a drill bit designed for plastic to prevent the plastic from melting or cracking. When drilling into drywall, use a drywall screw gun or a drill with a clutch to avoid overdriving the screws and damaging the drywall. When drilling into metal studs, use a self-drilling screw or a metal cutting drill bit to penetrate the metal without damaging the drill. When drilling into plaster, use a plaster drill bit or a multi-material drill bit to avoid cracking or crumbling the plaster. When drilling into brick, use a brick drill bit or a hammer drill with a carbide-tipped drill bit to penetrate the brick without damaging the drill. When drilling into stone, use a stone drill bit or a hammer drill with a diamond-tipped drill bit to penetrate the stone without damaging the drill. When drilling into fiberglass, use a fiberglass drill bit or a multi-material drill bit to avoid splintering or cracking the fiberglass. When drilling into laminate, use a laminate drill bit or a multi-material drill bit to avoid chipping or peeling the laminate. When drilling into MDF medium-density fiberboard, use an MDF drill bit or a multi-material drill bit to avoid splintering or crumbling the MDF. When drilling into particle board, use a particle board drill bit or a multi-material drill bit to avoid splintering or crumbling the particle board. When drilling into plywood, use a plywood drill bit or multi-material drill bit to avoid splintering or delaminating the plywood. When drilling into hardwood, use a hardwood drill bit or a high-speed steel drill bit to create a clean and accurate hole. When drilling into softwood, use a softwood drill bit or a high-speed steel drill bit to create a clean and accurate hole. When drilling into end grain, use a brad point drill bit or a Forstner bit to prevent tear out and create a clean and accurate hole. When drilling pocket holes, use a pocket hole jig and a step drill bit to create angled holes for joining wood together. When drilling dowel holes, use a dowel jig and a drill bit that matches the diameter of the dowels to ensure accurate alignment. When drilling for screws, use a countersink bit to create a recess for the screw head to sit flush with the surface. When drilling for plugs, use a plug cutter to create plugs that match the wood being used and conceal the screw holes. Consider a right angle drill. Right angle drills are designed for drilling in tight spaces where a standard drill cannot fit. The chuck is positioned at a right angle to the drill body, allowing for access to confined areas. They are commonly used in plumbing, electrical work, and automotive repair. The compact design allows for easy maneuverability in tight spaces. The right angle head provides access to areas that would be impossible to reach with a standard drill. Some models feature variable speed control for precise drilling. Look for models with a durable construction and a comfortable grip. Consider the size and weight of the drill, as this will affect its maneuverability. Check the chuck size to ensure it can accommodate the desired drill bits. Some models may have a magnetic base for added stability. Right angle drills can be corded or cordless, depending on preference and power requirements. A cordless right angle drill offers greater portability and convenience. A corded right angle drill provides consistent power and eliminates the need to recharge batteries. When using a right angle drill, always wear safety glasses to protect eyes from debris. Ensure the workpiece is securely clamped or held in place. Use the correct drill bit for the material being drilled. Start drilling at a slow speed and gradually increase it as needed. Apply consistent pressure while drilling, but avoid forcing the drill bit. Periodically clear away any debris or chips from the drilling area. If the drill bit gets stuck, stop the drill and try to remove it carefully. Inspect the drill regularly for any signs of damage or wear. Follow the manufacturer's instructions for maintenance and care. Be aware of the limitations of a right-angle drill, such as reduced power and torque compared to a standard drill. Choose a right-angle drill that is appropriate for the specific task at hand. When drilling at an angle, use a drill guide to ensure accurate and consistent results. When drilling into metal, use a cutting oil or lubricant to reduce friction and heat. When drilling into wood, use a wood drill bit with a brad point to prevent the bit from wandering. When drilling into concrete or masonry, use a hammer drill with a carbide tip drill bit. After drilling, clean the drill and drill bit thoroughly and store them in a dry place. If unsure about any aspect of drilling, consult a qualified professional or refer to a reputable guide or tutorial.